Hello everyone. In this session we're going to carry out a complex multiplication. We have already done complex multiplication examples. What is new about this example is that our complex multiplication is going to be a little bit more complicated because it will involve radicals of real numbers. Alright, so let us now multiply the number radical of 2 over 2 plus radical of 2 over 2 times I. Let us multiply that number by the number radical of 2 over 2 minus radical of 2 over 2 times I. Alright. First, the number u is equal to radical of 2 over 2 plus radical of 2 over 2 times I, and the number v is equal to radical of 2 over 2 minus radical of 2 over 2I. Now you can see that the two numbers are very close together, the two complex numbers that we're multiplying, but one has a sign plus and the other one has a sign minus in front of the term involving I. So the two terms are not quite the same. Alright. Now let us distribute all the parentheses. We are going to FOIL the entire expression. First we're going to multiply the first terms of the two parentheses together. We get radical of 2 squared divided by 2 squared. Next we're going to multiply the outer terms, radical of 2 over 2 times minus radical of 2 over 2 times I. So altogether we get minus radical of 2 squared over 2 squared times I. Next we're going to multiply the inner terms, radical of 2 over 2 times I times radical of 2 over 2. So we get altogether radical of 2 squared divided by 2 squared times I. And finally we'll multiply the outer terms. So we get minus radical of 2 squared over 2 squared times I squared. Alright. Now these two terms, as you can see, cancel. We have the term radical of these two terms repeat. I don't know if you see it, but they're the same except that one has a minus here and the other one has a plus there. So the two terms cancel. Okay, now radical of 2 when we square it, we get 2. And the number 2 when we square it, well, we get 4. So that term over there simplifies to 2 over 4. And this term, well, radical of 2 squared again simplifies to 2, and 2 squared again simplifies to 4. But here's a new thing. Remember, I was the imaginary unit, so we had that I was the number whose square was equal to -1. So when we square I, we get -1. So that I squared is replaced with this real number. Alright. Now 2 over 4 cancels down to 1/2. Same with this 2 over 4. And the two minuses give you a plus. So minus minus 1 gives you a plus 1, and 1 times 2/4 is just 1/2. Now 1/2 plus 1/2 is equal to 1, and that gives us the final answer to our problem. Once again, the complex number 1 is equal to 1 plus 0 times I, but we can omit the 0 times I. We do not need to write 0 times I. We can just write the number 1. One thing we see from this example is that it is possible for the product of two complex numbers to be a real number. Of course, we kind of knew that from before because I squared, that was -1, and that was also equal to I times I. So we already knew that it is possible for the product of two complex numbers that are not real. It is possible for a product of two complex numbers that are not real to be real. We knew that from before, but we see that there are relatively fancy ways in which this can happen. So it was by no means obvious that this complex number times this complex number, it wasn't obvious that the product of these two complex numbers is going to be real. But it did happen. So There is actually a good explanation, a good geometric interpretation of when the product of two complex numbers is real, but I will postpone that explanation for a more detailed exposition of complex numbers.